You've got 7 services to build, 3 in Go, 2 in Node.js, 2 in Python. And every time someone pushes to main, your CI pipeline crawls through each one, re-downloading every dependency, rebuilding everything from scratch, taking 15, sometimes 20 minutes. And you're sitting there, waiting. I've been there, and the thing is, Docker already has the tools to fix this completely. Most people just aren't using them. When I first showed my team what BuildKit and Bake Together could do, our builds went from over 10 minutes down to around 90 seconds, and they literally didn't believe me. I had to run it twice in front of them. Honestly, some of them still don't believe it was real, because it just felt too fast. In this video, I'm going to show you exactly how that happens. We're going to walk through a real demo project, those same 7 services, and evolve the Docker files step by step. By the end, you'll have cache mounts, multi-stage builds, a full bake file with a registry push, and registry cache, tar export, and spawn generation. Let's get into it. So first, what even is BuildKit? Because there's some confusion around this. BuildKit is Docker's modern build engine. It's been available since Docker 18.9 and is the default engine in Docker Desktop and Docker Engine 23 and above. If you're on an older setup, you can enable it with one environment variable. That's it. The old legacy builder, the one most people picture when they think of Docker build, runs every Docker file instruction in sequence, one after another. BuildKit does something fundamentally different. It builds a dependency graph of your Docker file and runs independent stages in parallel. It also supports a feature called cache mounts. We'll get to that in a second. And it has a completely different caching model that actually works well with CI pipelines. The demo project we're using has 7 services, 3 Go services, a REST API, a background worker, and a DB migrator, the 2 Node.js services, and 2 Python services that compiles to standalone binaries using Nuitka. I picked this mix intentionally because each ecosystem has its own package manager and its own caching behavior. What you'll see is that BuildKit handles all of them the same way, with the same syntax. Let me pull up the project structure and walk you through each step. Here's step 1. This is the first Go service. And if you've been writing Docker files for a while, this looks familiar. We start from Golang 122, copy everything in, run go mode download, then go build. Simple and clean, but completely unoptimized. The problem is what happens on the second build. You change one line in main.go, Docker sees that the copy layer changed, so it invalidates every layer after it, including go mode download. So now it re-downloads all your Go modules again, over the network, even though nothing changed. And when you have 7 services, you're running Docker build 7 times, manually one by one, watching the same packages download over and over. The final image is also enormous, around 900 megabytes, because we're shipping the entire Go toolchain with a binary. That's the baseline. Let's fix it. Here's the same Go service, but a bit evolved. This is where BuildKits start doing things the legacy builder literally cannot do. That flag tells BuildKit to attach a persistent cache volume to the build step. The Go module cache lives at Go package mode inside the container, and BuildKit keeps it alive between builds, outside of the image layers, in its own cache store. What that means, practically, the first time you build, Go mode download runs normally. The second time, even if you changed your source code, Go mode download is skipped entirely, because the modules are already there. Same for the Go build cache. Incremental recompilation. Only the files that changed get recompiled. For Node.js, it's the same idea. We mount root.npm, npm reads packages from there, before ever touching the network. Python with Nuitka is the most dramatic one. Nuitka compiles Python to C, then compiles that C code. That second part, the C compilation, is genuinely slow, but uses Ccache internally. So we mount root.ccache Ccache and root.ccache Nuitka on the second build. The C compilation just doesn't happen. It reads from cache. The cache mounts are invisible to the final image. They're not committed as layers. The image stays clean, and the build host gets fast repeated builds. That's the trade-off of BuildKit. The build host gets fast repeated builds. Now let's deal with the image size problem. Here's our evolved same Go service. We split the Docker file into 2 stages. The first stage is the builder. It has the full Go toolchain. It downloads modules, it compiles the binary. The second stage is from scratch. Scratch is a completely empty base image. No OS, no shell, nothing. The result, a Go image that's around 8 megabytes, down from 900. For Python with Nuitka, this is especially clean. Nuitka's whole point is compiling Python to a standalone binary, so our final stage is Debian Bookworm Slim. No Python interpreter, no pip, no dependencies listed anywhere in the final image, just the compiled binary. From an operational and security standpoint, that's a very different attack surface than a full Python image with all your source code sitting inside. For Node, we go from the full Node 20 image to Node 20 Slim in the final stage, and we only copy in what the app actually needs to run, not the build tools, not the dev dependencies. At this point, we've got fast builds and small images. The next problem is the workflow. 7 services, 7 separate Docker build commands. Let's fix that. This is my favorite part, Docker Bake. Bake is BuildKit's answer to the question, how do you manage builds across multiple services in a readable, maintainable way? Instead of a long bash script full of Docker build commands, you write a declarative HashiCorp language file or JSON or a compose file if you prefer, and run Docker Buildx Bake. Look at the structure. We have a group default that lists all 7 targets. Each target block defines one service, what context to use, which Docker file, which build args, what to tag it as. We also have variable blocks at the top, registry, and tag, so you can override them from the command line without touching the file. Now the key thing, when you run Docker Buildx Bake, BuildKit looks at all the targets in the group and runs them in parallel. All 7 services building simultaneously, each with their own cache mounts, each on its own thread. That's where the 7 times speedup comes from. You can also run just one target, or preview exactly what Bake will do before it builds anything. That outputs a JSON representation of the fully resolved build plan. Really useful for debugging when variables aren't resolving the way you expect. The Bake file also reduces cognitive load on your team. Anyone can open the Bake file, read it, and immediately understand what gets built and how. Compare that to a bash script or worse, undocumented CI pipeline steps. Now, the Bake file works, but look at it honestly. 7 targets, each one almost identical to the next. Same context, same Docker file, same cache pattern, just a different service name. If you add an 8th service, you copy-paste another block. That's the kind of thing that starts to feel like maintenance work. The next step is to fix this with Matrix. Here's what it looks like. Instead of one target block per service, we have one target block per language, and a matrix inside it. When Bake evaluates this, it expands the matrix automatically. One concrete build target per item in the list. So Go Services becomes Go Services, Go API, Go Services, Go Worker, and so on. Each one gets the right value, its own tag, its own cache slot, all from a single block. And the name field controls what the expanded targets are called. You can build all 3 by running. That's useful when you're debugging one specific service. You don't have to touch the other 6. And the big win, when you add a new Go service, you add 1 string to the list. That's the entire change. You can also add dimensions to the matrix. If you later need to build for multiple environments, say staging and production, you add an env axis, and the matrix generates all combinations automatically. 2 axes with 3 values, each gives you 6 targets, all defined in the same block. Alright, let's open our final view. This is the full production version. Matrix targets, registry push, registry cache, tar export, and SBOM all in one file. First, registry push. In the previous version, we were building images locally. To push them, you add push to the command, but in current step, we explicitly set output type registry per target, which means each image gets pushed directly to the registry as part of the build. No intermediate step, no separate Docker push. BuildKit streams the layers to the registry as it builds them. Now, registry cache. This is the big one for CI. On a CI runner, there's no local build cache. Every job spins up a fresh machine. Everything is cold. Without registry cache, you're downloading and rebuilding everything. Every run, even if nothing changed. Registry cache solved this with 2 fields, cache from and cache to. Cache from pulls cache layers from the registry at the start of the build. BuildKit reads them and uses them exactly like a local cache hit. Cache to pushes updated cache layers back to the registry after the build completes, so the next run has fresh cache to pull from. The setting that makes this actually useful is mode max. By default, Docker caches only the final stage of a multi-stage build, but our builds have a builder stage with all the heavy work: the Go mode download, the Nuitka compilation, the npm install. Without mode max, none of that is cached. With mode max, every single intermediate stage gets pushed to the cache registry, so on the next run, even the builder stage is a cache hit. There's one more output type I want to show you: tar. In the bake file, we have a second group called tar export. Each target there is identical to the registry target, except the output is tar. BuildKit writes the image as a tar archive to your local dist folder instead of pushing it anywhere. When is this useful? Air-gapped environments, service that can't pull from a registry, long-term artifact storage, or just when you want to ship a specific build as a file attachment. You can load a tar back into Docker with Docker load, or ship it directly on the server and load it there. In the final bake, we have this block in common target. Every target inherits from common, so every image gets both attestations automatically. What does this actually do? This bomb attestation triggers BuildKit's built-in scanner powered by Sift under the hood, which scans the contents of your final image layer and produces a manifest of every package, library, and binary it finds. That manifest is attached to the image in the registry as an into attestation. Not a separate file, it lives inside the image manifest itself. To inspect it after you push, simply execute. For the Python Nuitka services, this is actually interesting. Nuitka produces a compiled binary. From the outside, it looks like a black box. This bomb scanner still inspects it and surfaces the system libraries it's linked against, so you get visibility even into compiled artifacts. Why does this matter? Supply chain security. If a CVE drops for a library you're using, you want to know which images are affected without manually inspecting each one. With SBOMs attached, your security tooling can query the attestations directly. Regulations and compliance frameworks like SOC 2 are increasingly expecting this. A few mistakes I see people run into with all of this. The first one, forgetting load or push when using Buildx build. When you run Docker Buildx build without specifying an output, the image builds successfully and then disappears. It does not go into your local Docker daemon automatically. You need load to send it to the daemon or push to send it to a registry. With bake, you set output directly in the target block, so this is less of an issue, but it trips people up badly for the first time. Second, mode min versus mode max for registry cache. The default is mode min, which only caches the final stage of the build. For a simple single-stage Docker file, fine. For multi-stage builds, which you should be using, it means your build stage never gets cached. Your npm install, your go mode download, your Nuitka compilation, all called every time. Always set mode max for multi-stage builds. Third, cache mount permissions. If your build runs as non-root user, but the cache mount was created by root, you'll hit permission errors. This comes up with Python and Nuitka builds specifically. Make sure the user running the run instruction has write access to the cache mount target. The simplest fix is either run as root in the builder stage or set the UID and GID on the cache mount explicitly. Fourth. So let's look at what we actually built here. Step 1. Plain Docker build. Slow, sequential, rebuilds everything every time. 900 megabyte images. Step 2. Cache mounts. Go modules, npm packages, pip, Nuitka, C compilation, all cached between builds. Rebuild times drop significantly. Step 3. Multi-stage builds. Final images are tiny. Go services at under 10 megabytes, Python services as standalone compiled binaries with no Python interpreter. Step 4. Bake. One command, all 7 services in parallel. Readable declarative config. Readable declarative config that your whole team can understand. And then matrix, 3 target blocks instead of 7, where adding a new service is a one-line change. Step 5. Registry push. Registry cache with mode max, tar export for air-gapped environments, SBOM, and provenance attestations attached to every image. That's the full stack. And when all of these things compound together, that's where you get the 7 times speed up. All the demo files are in the repo linked below. Every step, every Docker file, every bake file, with comments explaining what each line does. Go clone it and run through the steps yourself. If you want a follow-up video on multi-platform builds, building for x86 and ARM architecture in a single bake command, drop a comment. I'll make it if there's interest. Like the video if it saved you some build time. Subscribe if you want more of this kind of content. I'll see you in the next one.